This video is going to cover your final exam study guide. The first page looks like this, and we're going to start on key concept number 1. So the first key concept that's going to be on your final is evaluating functions from a graph, a table, and an equation. So the first type of question you might be asked would be from a table. So evaluate d of 9. The key thing to remember with function notation is whatever is inside the parentheses in function notation is your input, otherwise known as your x value for that function. So when my input into the function is 9, I'm going to see where in my table where x is equal to 9. I can see the corresponding output value is 15. So d of 9, where 9 is my input, corresponds to the output value of 15. So a good thing to remember on the exam, you're going to see a lot of problems that have the word evaluate. So just as a little side note, in math when we're asked to evaluate a function, it means given an input value, find corresponding output value. So given an input value, find the corresponding output value. That's what we just did, so we completed the evaluation. Example 2 says, given this equation, evaluate f of x plus 4. So what this means is given the input of x plus 4, plugging into the function, what is the output going to be? So what I'm going to do is every time I see an x in this equation, I'm going to replace that x, that input, with x plus 4. So instead of an x here, I'm going to write x plus 4. That's still going to be squared plus 3. And again, instead of an x here, it's going to be replaced with x plus 4 minus 7. And here's my output. I could leave it like this. I could also go the next step and simplify. So I'm going to do that. I'm going to expand this into x plus 4 times x plus 4. I'm going to distribute this 3 here. So I get plus 3x plus 12 minus 7. Now I'm going to distribute out this binomial. So first term x squared, middle 4x, outside 4x, and then the last two terms, 4 times 4 is 16, plus 3x plus 12 minus 7. My last step is going to be to combine like terms. So x squared, 4x, 3x is 8, 9, 10, 11x, plus 16, plus 12 minus 7, 16 plus 12 minus 7 is 21. And that would be my final output. That corresponds to the input of f of x plus 4. Okay, and the very last representation you might be asked to do this for is a graph. So given the graph below, evaluate f of 3. The same rule follows. Whatever is inside the parentheses is our input or our x value. So what this expression is asking us is when the input is equal to 3, or the x value is equal to 3, what is the corresponding output or y value? So here I can see when the x value is equal to 3, the output, the corresponding y value, is equal to negative 4. So that the point, we could think of it, is 3 comma negative 4. So when my input is 3, my output is negative 4. Key concept is inside changes versus outside changes. For this, the key thing to remember is this expression, f of x minus h plus k. Remember, this constant h always represents an inside, what we call an inside change, because it's inside the parentheses, and it results in a change in inputs, so it causes a horizontal shift. And in a function, any change that happens on the outside is an outside change. It's going to cause the outputs to shift, meaning it's going to cause the y values to shift, which is going to result in a vertical shift. So outside changes are vertical shifts, inside changes are horizontal shifts. So for example, if we have this original function f of x equals x squared, and we transform it into this function that's exactly the same, except it has a -2, we'd ask ourselves, is that an outside change or an inside change? And since it's inside the parentheses, we can see it's an inside change. Therefore, we know it's going to result in some sort of horizontal shift. So the way we describe the transformation would be a horizontal shift. It's a negative, so we might be tempted to say it shifts left, but remember, for inside changes, the sign actually flips. So you might want to remind yourself. The sign flips. It's because of this negative here that the sign flips. So it's actually going to be a horizontal shift right by 2 units. And this next one, same idea. We have this original function that's being transformed, but now this -2 is outside the parentheses. So this is going to be an outside change. We know outside changes result in vertical shifts. So we'd say outside change is going to be a vertical shift. And since it's a negative, it's going to be a vertical shift down by 2 units. All right, next is writing function rules for piecewise functions. So this is going to be a free response question on your test. You're going to be given a graph, and you're going to have to write a equation for that piecewise function. So the general structure for a piecewise function equation is y equals, and then here we have 2 lines, so we're going to have 2 equations. Sometimes you have 3 lines, you have 3 equations. And then, so on the left here is going to be where we write our equation. And then on the right is where we write the domain for which this equation exists. So we're going to have some sort of domain here on the right. So let's start off with the equations. Here I can see this first line is a horizontal line that passes through, it looks like, oh no, it's kind of hard to see from this, but it looks like a 4 to me. So it's a horizontal line that passes through the y value of 4. So since it's a horizontal line, the equation is just y equals 4. It's just a constant function. There's no slope. So y equals 4. And then this function is a linear function, the next one. And we can see that it has a negative slope, and it passes through the y intercept of -3. So if I use the form y equals mx plus b, I know the y-intercept looks like, I'll label it right here, y-intercept looks like a value of -3. And if I were to look at the slope, if I were to count rise over run, it looks like it's going to be -2 over 1. So the slope off to the side here is rise over run. The rise is -2 and the run is +1. Therefore the slope is going to be equal to -2. So it's going to be -2x minus 3 for that final equation. So we write the equation here, -2x minus 3. And then the domain for these 2 equations. So for this first function, I can see it starts at the x value of -1, and then it exists to the left of or less than -1. So I'm going to say the domain of this function exists for all x values that are less than, my arrow is pointing left to show the functions to the left of -1. The last thing I would ask myself, is it an open circle or a closed circle? Since it's a closed circle, I'm going to say less than or equal to. Okay, and then the domain for the last one is going to be the opposite. It looks like it's to the right of -1, so it's all x values greater than. Again, my arrow is going to be pointing right to show it's for x values greater than -1. And since this is an open circle here, it's going to stay like an open inequality here. Okay, for this type of problem, I would go back and look at the Unit 1 and the Unit 2 study guides to see 2 more examples, as well as the playlist. This is definitely a type of question that you'll want to practice and review on Delta Math, on your old problem sets, in old videos before the test. Okay, composite functions and inverse functions. We actually just had mini lessons on these on Thursday and Friday in class. So what I'm going to have you do is, instead of including that in this video, I'm going to refer you back to those 2 mini lessons to copy down the notes to complete the study guide. This was mini lesson 2.5 about composite functions, and this was also under mini lesson 2.5. And you can also find these videos on the playlist, as well as if you scroll down. Okay, and then last 2 key concepts on the exam are average rate of change and equations of parallel and perpendicular lines. So average rate of change, this was a huge Unit 1 concept, and we just spent a lot of time reviewing it last week. Let's go through a quick example. I'm asked to find the average rate of change. I'm given a function, and then I'm given 2 x values, 0 and 4. I'm going to say 0 is my A, and 4 is my B. And because I'm looking for average rate of change, I'm going to use that equation that I have memorized, which is f of B minus f of A all over B minus A. Then I'm going to go ahead and plug in my A and my B values that I'm given. So I'm going to do f of 4 minus f of 0 all over 4 minus 0. And then the bottom of my fraction is easy to evaluate. I can just, 4 minus 0 is positive 4. Then to evaluate f of 4 and f of 0, I'm going to have to think back to key concept number 1 and use this function notation and use this equation to evaluate. So f of 4 to start, and use this equation, 4 squared plus 2 times 4 minus 8. That's 16 plus 8 minus 8. Plus 8 minus 8 cancels out, so I'm just left with 16. So I'm going to plug in 16 here. Because f of 4 is equivalent to or equal to 16. Therefore, I can say f of 4, in my equation, I can replace that with a 16. And then f of 0 squared plus 0 minus 8 is going to give me a negative 8. So that's 16 minus negative 8. Minus a negative is a plus, so 16 plus 8 is 24. And 24 divided by 4 is 6. So my final answer for the average rate of change is 6 for this equation between x equals 0 and x equals 4. All right, another, just to remind you, some of you prefer for this average rate of change to use the equation y2 minus y1 over x2 minus x1. That's completely that works, and many of you have a strategy where you create two ordered pairs using these x values, you end up doing the same math and getting the same answer. So just a reminder if that's what you prefer. Okay, this video is getting pretty long, so last key concept, writing equations of perpendicular and parallel lines. For these problems, you'll normally be given a line. So let's start with y equals 2x minus 3. So a line in the form y equals mx plus b, where the m, or the 2, is the slope, and the 3 is the y-intercept. And there's kind of two different directions the question could go. So let's split this in two. One thing you could be asked is to find equation of parallel line that goes through a certain point. So we'll say through 1, 1. You could also be asked to find equation of perpendicular line that goes through that same point 1, 1. So same problem, the only difference, one would ask you for parallel, one would ask you for perpendicular, and you'll end up with a different answer. So to find the equation of the parallel line, key fact to remember here is that parallel lines have the same slopes. Parallel lines have the same slope. So I know that whatever line I write, it has to have the same slope as my original line that I was given. So since the slope of this line is 2, the parallel line also must, by definition, have the slope of 2. Now the question is, what is going to be the y-intercept of the parallel line? And the only really thing that I can do to figure that out is by using the point I was given. So I have an x value and a y value. I'm going to go ahead and plug in the point, meaning I'm going to, when I see a y, I'm going to replace it with a 1, and when I see an x, I'm going to replace it with a 1 as well. So I have 1 equals 2 times 1 plus b, 1 equals 2 plus b, b equals 1 minus 2, or negative 1. Now I'm going to write my final line, y equals 2x, and then the b I just found, the y-intercept I just found, was negative 1. So there is my parallel line that goes through the point 1, 1. Same question, one particular line that goes through 1, 1. For this one, the key factor I have to remember is that perpendicular lines have opposite reciprocal slopes. So the slope of my original line is 2. The slope of my perpendicular line is going to be the opposite reciprocal, meaning since this 2 could be thought of as 2 over 1, the reciprocal, I'd be flipping the numerator and the denominator upside down. So the slope is going to be 1 over 2. And then because it's the opposite reciprocal, not only do I flip the fraction upside down, but I also add a negative, or the sign changes. So if it's positive, it becomes negative. If it were negative, it would become positive. So the slope of my perpendicular line is going to be negative 1 over 2. So it's going to be y equals negative 1 over 2x plus b. How am I going to find the y-intercept? Same strategy as before. So I'm going to plug in my point, 1, 1. 1 equals negative 1/2 times 1 plus b. Anything times 1 is just itself. So I'm going to get 1 equals negative 1/2 plus b. And then when I add 1/2 to both sides, I'm going to get b equals 1 1/2. So just to be clear, this last step I'm adding 1/2 to both sides to get 1/2. That cancels out, and then 1 plus 1/2 is 1/2. So now my final answer is going to be yx plus 1.5. In decimal form, that would be y equals negative 0.5 x plus 1.5. So both of those would be the correct answer. One is in fraction form, one's in decimal form. So they both could be the correct answer on your test. All right, that concludes your study guide. What I highly encourage you to do is use these same types of example problems I just gave you. You know that they will all show up on the test, and try plugging in different numbers, try changing small things about the equation. You can completely make up all of your own practice questions using just the basic structure of these questions that I've given you, because that's how I'm going to write your exam, is just by changing little things about these questions. Okay, thank you for your attention. Happy studying. Please reach out, come to office hours. Don't be shy. Happy studying.